Okay, now we're going to go up on this roof and install a solar-powered attic ventilation fan. This is the shingle roof. Eric's going to completely explain the entire process so you'll understand how to place it, how to install it, and what the end performance will be. So Eric, let's go ahead and get that done, all right?
Okay, great. Okay, everybody, now we're on the roof of the home where we're going to be installing our low-profile solar-powered attic fan. And we want to make sure that we locate the fan directly in the center of the two framing members. So we want to make sure we're in between both of the rafters going down the roof. And I want to show you a couple different ways that we can determine that. The first way is to measure the overhang on the building. So if I just reach over and measure my overhang, I've got a 16-inch overhang to where my framing starts. So if I come back here and measure 16 inches in, that's where my common framing would start, and I can go every 2 feet from there and there would be a framing member. So if I went 2 foot, 4 foot, 6 foot, 8 foot, and so on, that will help you establish the layout and help you understand where to put your fan. Now for those of you with a little bit more experience, there is an easier way. And we can tell just by the sponginess of the roof. Can you see how spongy that is and how much it gives as I bounce on it? Now if I come over here, it doesn't do that at all. And that's because I'm standing directly over one of the rafters. Does that make sense? Okay, so what we're gonna do is we're gonna apply both methods to double check ourselves and make sure that we're accurate. So we're gonna go ahead and do that. The other thing I'd like to show you is at the moment, the roofers have located 2 passive vents on this roof. Now we would like to center our fan over this living space, so we're going to locate our fan in between these 2 passive vents, and then we're going to have to go back and make sure that we block these vents so that the fan will draw intake from the lower end of the roof. And this is strictly for aesthetics, to make sure that we look like we're centered. We want to check that. We've got 14 feet between them, so 7 feet would be the center. So here's our center. And we've confirmed that that's between 2 roof trusses. So we're going to go ahead and establish our point down from the roof, or down from the ridge, which will be 2 feet. Guys, make sure that when you're taking your fan out, you can use some of this cardboard to set the fan back down and keep it nice and protected. Can I have that other piece too, please? Thank you very much. And that'll help protect the surface of this nice, beautiful embedded solar panel. Okay, and that's going to be just enough for me to slide my tape measure in here. I'm going to slide it in here to the point where I know it's hitting. I might need to make my hole just a little bit bigger. Okay, so we've got our inspection hole. I'm just going to stick my tape measure in here and find the next truss. So we're 8.5 inches from my inspection hole. Bring my tape measure on top. Here's 8.5 inches. That means my truss is right here. So what we're looking for is your inside diameter of your pattern to be inside this line. So long as this edge is inside 8.5, we're going to be well in the center of this cavity. The next step here, you guys, is going to be able to take our razor knife with a hook blade and we're going to remove these shingles. And the reason for that is these asphalt shingles can be known to gum up your blade. You can see that they're already gumming up our Sawzall blade here, and that can make it a whole lot more difficult when cutting a hole in your roof. It's a whole lot easier just to remove these shingles with a hook blade. We'll show you how to do that next. Okay, as you can see, we've removed all of our asphalt shingles from our roof decking, and now we're ready to go ahead and cut our hole with our Sawzall. It can be a whole lot more helpful to get a pilot hole on the perimeter so you don't have to make a cut and turn with your Sawzall. And it can be helpful to make a couple. That allows you to go a couple different directions with your saw. Now make sure that you guys either have a screw in this so you have something to hold on to if you don't have a hole in here. And it's nice to have a partner to help you catch this. If this were to fall into the attic, it could potentially cause a hole or damage to the drywall down below. There we go. Jason did a great job cutting a nice perfect circle. You want to make sure that you cut perfect 16-inch diameter circle, just exactly what's on the pattern to allow as much air to come through the fan as possible. Now the next step what Jason's doing here is he's going to go ahead and start breaking the tar strip on these shingles. And the reason we're doing that, there's a tar strip that seals these shingles down at the bottom of every course of shingle. Okay, I'd like to show you guys a method to break this tar strip without causing damage to the shingle. It's nice to use your hand or a hammer to just lightly tap on this tar strip. Now you really have to watch what you're doing as you're going, and you may need to change your point of attack occasionally to make sure that we're not coming up through this shingle. It's always necessary to keep a downward angle on your flat bar. And once we get it started, typically they come up pretty easily. There we go. And what we're looking for, guys, is to come about 6 inches on each side so that our flashing will slide up in here. Okay. So we've appropriately broken our tar seal. Now when we go to slide our flashing in here, there's going to be roofing nails sporadically around the diameter of our hole. So what Jason's going to do is we're going to change to a metal tip blade, and he's going to slide that blade up under here, and he's going to go just like this with his Sawzall around the radius, and we're going to buzz those nails off so that they're not impeding the flashing from getting up underneath our shingles. Now when you're doing this, it's highly important to make sure that you keep your blade flat with the roof so that the blade doesn't come and cut through your upper shingle.
Once you go all the way through, you know you've got all the nails cut.
Okay, the next step, you guys, is to go ahead and make sure our fan's gonna fit. So Jason's opening up our shingles there. You wanna be nice and careful and slide it up in here. And what we're looking for, Jason's checking the reveal on his side, and we're looking to make sure that the reveal is the same all the way around the shingles that we cut to make sure that the fan is centered directly over our hole. What do you think, Jason? That looks pretty good.
Looks really good.
Okay, so we're going to pull this back out. Jason's going to prepare our caulk gun, and we're going to apply some sealant to the bottom of this flashing. Another thing that's highly important is make sure you guys keep the roof clean as you go. Roofs can be very windy places. If any of this were to go blowing off the roof, you could see this could be very dangerous if we were to allow that to blow off the roof. So make sure you keep your roof clean. Okay, now this next step is definitely easier with two people. I'm going to be responsible for my side and Jason's going to be responsible for his side. And the goal here is to be able to slide this fan in without smearing our sealant all over the roof. So what each of us are going to be doing is holding up the shingles where we broke our tar seal and very carefully sliding this fan in while maintaining a slightly upward angle. Jason's getting ready to apply our fasteners. These are hex head nut-driven screws with washers on them. Okay, so we're going to have Jason put one screw in each bottom corner. Okay, that looks great. And then as you can see, we've got this tar seal up. That's a great place to put a screw, and we'll let that shingle roll back over that and shed water. So I'll hold that up for Jason. The last step after we come back after all these fasteners is we're going to make sure that we apply some new sealant and redo the seal that we've broken. After you're done applying your sealant, it's important to relieve the pressure, otherwise your tube of sealant will continue to expel sealant and it can end up smearing all over the roof and creating a big mess. And make sure, everybody, that you get a good seal with a nice, good polyurethane sealant around. What would you say, Jason? That took us maybe a half an hour? About a half an hour. So most fans, everybody, should be able to do inside an hour, barring any unusual circumstances.
Eric, I've got some questions for you and Jason. I see you've done a beautiful job on installing the solar fan. I'd like to go over with you some of the features, both you and also for the listening audience, really what makes this product different from all the other products in the market. I know you'll know a lot of the features, but I'd like to take some time to really go over the details because all solar fans are not created equal. There's a huge difference in terms of performance and quality from this particular product and every other product in the market. So let's look down here closely at the actual construction of the material. 100% of all the parts you can see are all made out of aircraft grade aluminum. You know why that's important? Why don't we make it out of plastic?
It prevents the fan from rusting.
Well, it'll help it from rusting, but also the big problem with plastic on the roof is it will degrade rather quickly, especially here in places like New Mexico and Texas and South America and
Well, I can tell you, I've worked on roofs in almost every part of the country, and in every part of the country, roofs are very extreme climates.
Well, you're sitting up here on the top of this roof. It's going to be looking at the sun without any protection, 12 to or more hours every day in the sun. And so if we don't make this out of really super high quality material, it's just not going to last. So there's no steel components in here. This is all made out of aircraft grade aluminum, so we're never going to have a rusting problem. The solar panel on the top is the highest grade polycrystalline solar panel made. It's made in our own factory. So this is a super high quality solar panel. It makes an excess amount of energy so that this system can actually operate, and we know we're going to get a long life cycle. Talking about life cycle, the projected life cycle on this product is between 42 to 45 years. The average competitive product, guys, as you may or may not know, is typically 1 to 3 years. If they put a thermostat in their unit, they can sometimes extend the life to 5 to 7 years. But then you're not operating in some of the most important climate which is the cold climates. So we typically will not put a thermostat in these units, and that's so that the unit will operate in the winter and the summer. Okay, so let's take another look at some of the features. Underneath this unit, there's another very important component underneath the hood here. And what that component does, it helps to deflect the light so that the light will exit out of the unit more efficiently. We pick up 30% improvement in performance right there. And then the motor, which is one of the most important parts of the system. It's a brushless DC motor with built-in MPPT technology, which helps it to harvest more energy with lower amounts of sunlight. So it'll start working earlier in the morning and it'll work later in the afternoon. Under certain circumstances, we do offer a tilt model, which is very applicable in certain conditions where you cannot put this in an area where the sun is looking at it, but majority of our installations will use this embedded unit. As you can see, it's aesthetically very beautiful.
Very good.
These are all handmade in our factory in New Mexico. All American made. We're real proud of that. We hope that the folks out there watching the video believe that that's important. That's putting Americans back to work.